Welcome back. Today we will discuss some more examples on question spaces. So over here a vector space P4 of x is given to us, which is space of polynomials having degree less equal 4 along with what 0 polynomial. We have already seen that it is a vector space with dimension 5. So one more linear transformation is given here. One more in the sense one a linear transformation is given here. Okay, so which is d stands for derivative. So p4 of x to what p4 of x, and it is defined as d of f is equal to df upon dx. So in the sense, this f is a polynomial in p4 of x, and after you operate d on that f, so what will that function do? It will just take the derivative of that, and we will get what the derivative of it. For example, if our f is some x cube plus 2x square plus 3x plus 1, so if I operate d on it, so what will be my df? So it will simply take the derivative, so 3x square plus 4x plus 4 3. Okay, so this is what I wanted to say. So uh, so in this example what we have to do is, our w is kernel of d, and we have to find basis of w and the quotient space v mod w. Okay, so let us start then. Okay, so before going ahead, let us use some notation for this small f. Remember, this small f is from what domain, that is p4 of x. So I will say let f of x or f is equal to some a naught plus a1x plus a2x square plus a3x cube plus a4 x raised to what 4. Okay, therefore d of f, which will be equal to df upon dx, which will be equal to what? Simply take the derivative, so that is a1 plus twice a2x plus thrice a3 x square plus 4 a4 x cube. Is that okay? Now let us write down the kernel of t. So we have now over here not kernel of t but kernel of d, right? Because d is the notation used for the linear transformation. So what is the definition of kernel? Okay, so just I will recall it somewhere here. So this part you are not supposed to write in the exam, right? Whatever I write with the red pen. So if t from v to w is a linear transformation, then kernel of t is defined as it is a collection of v belonging to v such that t of v is equal to what 0 of w, right? So in this case our w is p4 of x, that is the codomain of linear transformation, and its 0 is nothing but what 0 plus 0x plus 0x square plus 0x cube plus 0x to the power 4, right? Now instead of using this v notation, which notation we use generally? Whatever notation is given in the question, over here f is used, right? So that notation we are going to follow, and our v, that is the domain, is also what p4 of x. So I will say it is a collection of what, so f belonging to p4 of x such that this d of f is mapped to what 0 of p4 of x, and it is 0 plus 0x plus 0x square plus 0x cube plus 0x raised to 4, right? So which is further equal to, so which notation we are going to use for f? Okay, f is equal to a naught plus a1x, obviously whichever I have written before, a2 x square plus a3 x cube plus a4 x raised to 4 belonging to p4 of x such that d of, now since this value of f I have taken, now directly I'll take the derivative of that, and the derivative is going to be, I have already written it, so a1 plus twice a2x plus thrice a3 x square plus 4 a4 x raised to 4 is equal to, okay, so is equal to 0. Now trying to understand, it is a bold 0, okay, so means this 0, which one, this one, right? So which is further equal to, now I will write it here due to space problem in the examination, remember you write it one below the other. So this is equal to, now I will remove this notation f, only a0 plus a1x plus a2x square plus a3x cube plus a4 x raised to 4 such that, now simply compare, okay, this polynomial and this, so equate the coefficient, so a1 will be 0, twice a2 will be 0 such that a1 is 0, okay, but twice a2 is 0 means what, a2 is 0, thrice a3 is 0 means what, a3 is 0, and what, similarly a4 is also 0, okay. So if you use these values, this will be equal to what, only a0, right? Now see, where this a0 is nothing but what, it is a real number, so it is of the type, it can be written as some a0 multiplied by what, 1, okay, that's it. So just now try to recall the definition of linear span of S, okay. So if your set is containing only one vector, so I will write it here, suppose your set S is containing only one vector, okay, that is v1 I will say. So what will be my linear span of S, it will be equal to, it is a collection of alpha 1 v1 such that alpha 1 belongs to what, R, right? So just observe this properly, okay, is it of the same type, obviously S, okay. So I will just clarify one thing, yes, okay, this is important, such that a0 belongs to what, R, and over here also such that this a0 belongs to what, R, okay. So just see this one, okay, this one and this one, you simply compare it, so you can see that our value of v1 is nothing but what, it is 1, right? So actually this is nothing but what, this is linear span of S, remember our left hand side is kernel of D, and in the quotient they are calling it as W, where what is our S, where S is nothing but what, it contains singleton 1, okay. Now we found out spanning set of kernel of D. Now we have to check whether it is linearly independent or not, that is we have to check whether S is linearly independent or not, but we know S is linearly independent, right? No issues with that because it contains a single non-zero vector, right? So whenever our set is containing a single non-zero vector, that set is linearly independent, okay. So if you want, I will write it here, S contains single non-zero vector, okay. So I will call it as some 2, and therefore from 1 and 2 you can say, therefore from 1 and 2 S is what, a basis, okay, of kernel of D, right? Now once we find the basis of kernel of D, we have to extend that basis to what, the basis of the vector space, right? And what is our vector space over here, it is p4 of x, right? So first of all I'll say from 1 and 2 S is basis of W only now, as W is a subspace of P4 of X, that is our V. Therefore, basis of W can be extended to basis of P4 of X. Now the question is, which elements we should add in S in order to extend it, okay, to basis of what? P4 of X. So one vector is already there in S, so we have to add how many vectors? This is the question. So before that I will mention the dimensions. So I'll say, since dimension of P4 of X is 5 and dimension of W is equal to 1, therefore we add how many vectors? We add 4 vectors in S, okay, and that came from where? Since this 5 minus 1 is equal to what? 4. So I will say let S1 is equal to, now one vector will be already there. Now what will be the other 4 vectors? We already know that this 1x, x square, x cube, x raised to 4 is standard basis of what? P4 of x. So which are the terms that are missing? Okay, which are the vectors that are missing? That vectors we are going to add in S1. Okay, so x, x square, x cube and x to the power 4 are missing, so I will add them. So I'll say let S1 is equal to x1, or it will be compulsory there, okay, because that one is carried from S, the set S. So 1 x and then x square, x cube and x raised to 4. Okay. But so now clearly it is a basis of P4 of X. Otherwise what we will check, if we are not sure whether it is basis or not, then I will write here to check S1 is linearly independent or not. Is that okay? And if it comes out to be linearly independent, then we can use the theorem. Once it is linearly independent and S1 contains 5 vectors, okay, and dimension of this P4 of X is also 5. So, and we have seen a theorem, the vector space is 5, then any linearly independent set from that vector space containing 5 vectors becomes what? Basis. Okay, so this is the idea, but over here no need, because we already know that it is a basis of P4 of X, since it is a standard basis itself. So I will say clearly this S1 is a basis of P4 of X. So therefore what is the basis of quotient space? Therefore basis of quotient space V mod W is equal to, so whatever vectors we have added, simply take bars of that, right? X bar, x square bar, x cube bar, x raised to 4 bar, or you can also write it as x plus W comma x square plus W comma x cube plus W comma x raised to 4 plus what? W. That's all about this question.